These are the Chapter 5, Note 7 on blocking. Today we're going to talk about block design. We'll look at some AP problems dealing with blocking. With block design, instead of running a single experiment with one sample, we're going to divide our sample into smaller subgroups called blocks, and we're going to run the experiment within each of these blocks. Here's how block design works. The first thing we do is we take our sample and we separate the individuals in your sample into blocks. What are blocks? Well, all individuals within a block should have something in common which separates them from any other block. If you're doing an experiment with football players, for example, your blocks could be based on positions. If I'm thinking of a football team and you're doing a football team meeting, you may have the entire group together, or what you may do is you may say, offensive players, we're going to have a little meeting with you over here. We're going to meet with our defense over here. And if you play special teams, if you're on the punt squad or kickoffs, our special teams group will have their own meeting. And the idea behind blocking is this. If you were the head coach of a football team and you wanted to do an entire team meeting and ask, hey guys, how's morale right now? Maybe with the entire team, people go, you know what, the morale's pretty decent. But then when you split the players up into groups, maybe on offense, the offensive players say, yeah, morale's great. The defensive players are like, boy, we're kind of struggling out here. Morale's not very good. And the special teams players might go, morale's terrible. You may get different results within each of these groups, and these results may differ from what you get from the big entire group. It's especially worthwhile when you talk about experimental data as well. If you're doing an experiment with students from Williamston High School, same idea. Your blocks could be based on ages. Because what you may find is if you did an experiment with the entire school, you may get one result, whereas you may get different results if you were to break the student body down into grade levels. So when you run a block design, the idea is you separate the individuals into blocks, you do random assignment within each block, and then you run the experiment within each block. And the results obtained from one block may differ from the results obtained from another block. This will make more sense when we take a look at this example from the 2004 AP exam. Researchers who are studying a new shampoo formula plan to compare the condition of hair for people who use the new formula with the condition of hair for people who use the current formula. 12 volunteers are available to participate in this study. Information on these volunteers, numbered 1 through 12, is shown in the table below. In Part A, researchers want to conduct an experiment involving two formulas, new and current, of shampoo. They believe the condition of hair changes with age but not gender. What this means is researchers are basically saying, you know what, as people get older, the hair kind of changes, but really there's not a big difference between male and female hair. Because researchers wanted the size of the blocks in an experiment to be equal to the number of treatments, they will use blocks of size 2 in their experiment. Identify volunteers by number that would be included in each of the 6 blocks and give the criteria you used to form the blocks. We are going to make 6 blocks. And inside these blocks will be 2 people each. When you make blocks, you want to make sure that the people or the individuals or the units within each block are similar. So what we don't want is I don't want there to be a young person and an old person in each block. What I want is for example, the 2 youngest people, which would be like the 20 and 21-year-olds, numbers 1 and 2. I would want them to be in a block. They're my 2 youngest people. They should be in a block together. My next 2 youngest people are 23 and 24 years old. They should be in a block. We'll call them people 10 and 11. The next 2 youngest people are both 44. They should be in a block. People of similar ages should be in the same block. And we'll do that for the 46 and 47-year-old, which are 3 and 12. The 58 and 60-year-old, they're people 4 and 7. And then our old fogies here, the 62 and 61-year-old, numbers 5 and 6. And how this experiment would actually work is, if you're testing a new shampoo with 12 people, you could give 6 of them the new shampoo and 6 the kind of the regular shampoo and go, hey, how does it work? And you may draw some sort of conclusion, which might be somewhat valid. But then you may find, you know what? When we did this experiment with the 2 young people, people 1 and 2, with young people, the new shampoo worked really well. But for old people, the old formula worked better. And the idea behind a block is now we have 6 separate experiments. And what we may find is that with the first group, the new shampoo works great. And maybe for the first 2 or 3 groups, the new shampoo works great. But then as you get to these older people, maybe it's the older shampoo that works better. So when you run a block experiment, what's kind of nice is you get to see not what the entire group thinks, but maybe what these smaller groups kind of see, and you may get some different relationships there. On part B, other researchers believe that hair condition differs with both age and gender. So these researchers think that it's not just age, but it's gender that also affects things. Researchers are also going to use blocks of size 2. So we're going to use blocks of size 2 again, but this time we want to make sure that within each block we have people that are similar not only by age, but by gender. In this case, it means that we want people of the same gender to be within each block. So what's going to happen is when we run the experiment, we'll have 2 people. They'll be of the same gender, same basic age group. One person would use the old shampoo, one person would use the new shampoo, and we'll see with young people of each gender which shampoo works better. And then we'll do the same for middle-aged and old people. Now the youngest male is 21 years old, the next youngest male is 23. We're going to group these 2 people together. They're 1 and 11. These are the young males. The youngest females are 20 and 24. There are 2 and 10 numbers. Our middle-aged men are 44 and 47, so we'll put them in a group, numbers 3 and 9. And our middle-aged women are 44 and 46, so we will put them in a group, numbers 8 and 12. Our oldest men are 58 and 61. We'll put them together in a group because they're similar by age and they're the same gender. And our oldest female contestants will be grouped together as well. And this is the idea behind a block. And what we would do to run this experiment is we would take the 2 youngest males, go, hey, you're going to take shampoo 1, you're going to take shampoo 2. We're going to compare what shampoo works better between those 2 young males, and we can make a conclusion based on that. We're going to skip over part C and move over to the next section. A matched pair design is a type of block design illustrated in the last problem we just worked at. Inside each block, only 2 treatments are used. Examples are pre-test and post-test, a new medication versus a placebo, and treatment A versus treatment B. Each subject can receive both treatments to compare, or 2 subjects can be randomly assigned to different treatments. We will talk more about matched pair design in February. If you're outlining a block design, what's different compared to what we did before is with a traditional outline, we were just concerned about this piece right here. We were doing one single experiment with our entire group. We may split the group into a couple of kind of subgroups where we do treatments and we compare. If you do a block design, you're going to take your subjects, and before random assignment, you're going to split them into blocks. So it may be we're taking the subjects, we're going to split them into males and females. Then within each of these blocks, you're going to do the random assignment, the groups, the treatments, and comparison. You aren't actually going to do this on problem 547. I think I mistyped this number here, but it will come up later down the road, and you'll see an example of this in your book on page 302. The last problem I want to take a look at today is from the 1997 test. This is a problem where we have a new type of fish food that's available for salmon. Your task is to design an experiment to compare the weight of salmon raised over a 6-month period on the new and old types of food. Salmon you'll use for this experiment have already been randomly placed in 8 large tanks in a room that has a considerable temperature gradient. Specifically, tanks on the north side of the room tend to be much colder than those on the south side because of this heater. The arrangement of tanks is shown in the diagram below. Describe a design for this experiment that takes account of the temperature gradient. What I would like you to do is I would like you to find a way of blocking the tanks here. How can you come up with a block of tanks that would have similar temperatures? So which tanks should be grouped together to run this experiment? What I'm going to have you do is pause the video, see if you can figure out which pairs or groups of tanks should be grouped together as having the same temperature, and then we'll talk about how you'd run the experiment. All right, to me, I definitely want to group together the 2 tanks that are closest to the heater. That'd be number 6 and 7. I think that should form one block. I would also say that the next 2 tanks that are closest to the heater would be groups number 5 and 8. They should form another block. Probably the 2 tanks closer to the door but kind of even with a heater, these guys should also be a block as well, so probably 2 and 3. And then 1 and 4 are close to windows, relatively close to doors, far away from heaters, probably the coldest of the tanks. These are your 4 blocks. And what we would do in this experiment is, with our block that's closest to the heater, these are the fish that are getting cooked already, what we do is we test and say, okay, if you're in tank 6, you're getting this type of food. If you're in tank 7, you're getting this other type of food. And we would compare, which tank do the fish respond more favorably to the food with. And what we may find is that with the tanks that are closer to heat, they may like the new food. Tanks closer to the door that are colder, they may prefer a different food. So by running this experiment several times under different temperature settings, we may reach different conclusions based on how we blocked our tanks. We will eventually take a look at our last problem from the 2001 AP exam as well, which deals with blocking schemes and determining which of these is a valid blocking scheme. We'll come back to these a little bit later on in class.